Hi and welcome. I'm trying to learn space science. Today, Proxima Centauri and IC1101. And after the assignment, we're going to do short impingement training. And if you participate in the short impingement training, then it's better. Now the question is here, can we visit the other stars in our galaxy? And here's now written, our nearest star, apart from the Sun, is called Proxima Centauri. At more than 40 trillion kilometers away, even our fastest spacecraft would take thousands of years to get there. Okay, there's the solar system with the Earth and the Sun, and the next closest star to the Earth is Proxima Centauri. So Proxima Centauri is the closest star to the Earth. It is 40 trillion kilometers away, apart from the Sun. Proxima Centauri is a fairly small, dim star. We can see it in the night sky without a very powerful telescope. We can't see it in the night sky without a very powerful telescope. So I read it correctly in the last part. Okay. Now we want to make a presentation. The infos we want to say is, one is, we want to make a presentation about Proxima Centauri. We want to say Proxima Centauri is the part of the Sun, the closest star to Earth. It is 40 trillion kilometers away. And let's add at that point of how the Sun is away. We are 140 million, I think, also. 150 million kilometers. 40 trillion. Let's spend 1 second on looking if we can calculate it. It's 1 million times the thing plus a third. I think it's 300,000 times the distance. Would it make sense? It are 8 minutes to the Sun, and I think it was 4 night years to Proxima Centauri. And this is 300,000 times the distance. 8 minutes is a 10 per hour around. That means 150 per day, 500 per month, 5,000 per year. No, it wouldn't be enough. It would be only 20,000. Okay, let's stop that calculating. We're going to say Proxima Centauri, the nearest star part of the Sun, 40 trillion kilometers away, 40 trillion, and the Sun is 150 million kilometers away. And Proxima Centauri is a pretty dim star. So this star, what is the closest one part of the Sun on the night sky, can be seen only with a telescope. These are good information. I have a second camera there, which I'm going to start now. I have a little grammatical problem. Proxima Centauri. Proxima Centauri is a part of the Sun, the closest star to the Earth. It is 40 trillion kilometers away from Earth. The Sun is 150 million kilometers. Even our fastest spacecraft would take thousands of years. Proxima Centauri. Proxima Centauri is a part of the Sun, the closest star to the Earth. It is 40 trillion kilometers away. The Sun is 150 million kilometers away. It would take thousands of years to get with a spacecraft there. It is a pretty dim and, what is the other name? Small, fairly small. Proxima Centauri. Proxima Centauri is a part of the Sun, the closest star to the Earth. It is 40 million kilometers. Proxima Centauri. Proxima Centauri is a part of the Sun, the closest star to the Earth. It is 40 trillion kilometers away from the Earth. The Sun is 150 million kilometers away. With a spacecraft, it would take thousands of years to get there. It is a fairly small and dim star, so that it can't be seen with the naked eye on the sky. The telescope has to be used. That is according to Isabel Thomas, Out of This World, on the page 31. I don't know, I didn't deliver now the conclusion that the other stars are further away, but they are brighter and they can be seen on the night sky. We have a conclusion. I'm going to stop the camera and start it directly again. said the other thing was IC1101. IC1101. How many stars are in a galaxy? First here, a galaxy is a group of stars, gas and dust held together by gravity. Let's start by looking at our galaxy, the Milky Way. The Sun is one of at least 100 billion stars in the Milky Way. We're going to use it as a comparison. We're going to say the Milky Way with the Earth in it, with the solar system and the Earth in it. The galaxy in which the Earth and the solar system are is the Milky Way, and that is 100 billion stars, 100 billion. Many of these stars are bunched together towards the center of the galaxy. The Milky Way is huge. Even light takes 100,000 years to cross. That is our second comparison, 100 billion and 100,000 years to cross for the light from one side to the other of the Milky Way. But in galaxy terms, it is just medium-sized. The largest one ever spotted is called IC1101 and has up to 100 trillion stars. It is more than 50 times the size of the Milky Way. The center of our own galaxy is a cluster of at least 500 million stars. It is one of the brightest things we can see in the naked eye. Okay, we're going to say IC1101 is the largest galaxy which was found by humans so far. To name a date. Let's just keep it open. So far. And it has 100 trillion stars. The Milky Way, in which the solar system of the Earth, in the Milky Way, the galaxy in which the solar system of the Earth is, has 100 billion stars. Do we say it is 1,000? It must be 1,000. Let's keep it on. And that IC1101 is a galaxy which is 50 times larger than the Milky Way. And already the Milky Way, it needs 100,000 years to travel for light from one side to the other. Let's try it. IC1101. IC1101 is the name of the largest so far found galaxy. And it is 50 times larger than the Milky Way. The Milky Way is the galaxy in which the solar system of the Earth is. And already in the Milky Way, the light needs 100,000 years to travel from one side to the other one, and that IC1101 is 50 times larger. The Milky Way has already 100 billion stars, and that IC1101 has 100 trillion stars. That is according to Isabel Thomas, Out of This World book, page 30. Oh, I said it right. I turned it around. I wanted to say it the other way around. Now I'm going to stop the camera, and I think let's wait a second. Do we make another video in which we say the Milky Way has 100 billion stars? I think that's a good fact. So I'm starting my camera again. And now we're just going to say, basically just a question, how many stars are in the Milky Way? 100 billion. 100 billion. As a comparison, IC1101, the largest one so far found has 100 trillion. No, let's not confuse the people. Just one number. 100 billion. Just that, nothing else. Do we say that 500 million of them were in the center bunched together? Which is much less than 100 billion. No, just the 100 billion. 100 billion. The Milky Way has 100 billion stars in it. And that is according to Isabel Thomas, Out of This World book, page 30. Now I'm going to stop the camera. And wait for space science. If you were here for space science, you can go directly to the next part of space science. We will do now the short and impingement training. If you stay and participate in the short and impingement training, then it's better the hours. Go in a stable stance, and we're doing shorter circuits. Come back. Up, short, and down. And backwards. Now, long arms, strong fists, and go as far back as you can with the shoulders. Higher up, front, down, and back, up and down, and up backwards, up and back, down, and front. And the next exercise, the accelerating motorcyclist, legs wide apart, hand to the knees, hinge forward with a straight back, let the arms hang and pinch the scapulars together with it. Fists, lift the arms up and still pinch the scapulars together. Set the arms down, and shoulders, and then over around, pinch the scapulars together. fists, lift the arms up and pinch the scapulars together. Arms down, shoulders down, and the sheet jumper into the knees, hinge forward, with the joint back, let the arms sink, make fists, turn the arms to the inside, lift the arms high up, bring them together, straighten up, bring the shoulders down, hands together. Arms up, together, shoulders down, together. Second round, to the knees, hinge forward with the joint back, with the arms hang, make fists, turn the arms to the inside, arms high up, hands together, straighten up, shoulders down, hands together. And just lift the arms up. If this or any other exercise causes pain, then don't do it. Again. And the arms to the side and in front. And now, we will lift up. Put the same stance, long arms, strong fist, shoulders down, hands together, and turn the arms to the inside. Arms to the outside, shoulders down, hands together. Arms to the inside, shoulders down, hands together. Last time, arms to the outside, shoulders down. These arms to the side, up, a bit in front, turn the arms in front, shoulders down, hands together. Arms back, shoulders up, and front. And switch, arms in front, shoulders down, hands. Switch, arms back, shoulders up, and in front. The shock. Lift the arms up, shoulders up, and down. Again, the arms up, shoulders up, and down. Arms up, shoulders up, and down. Now for pretzel curl, arms together, get down to the outside. That was the last time. And now, sometimes I have a sock or something with a long arm at the outside. Let it fall down and try to catch it. Try to keep a straight arm. And on the other side. And last exercise, stretching one arm in front. Shoulders back and down. Pull the arm in, have his fingers, try to relax the arm. Go with back of the shoulder, turn the palm up to the sky. And the arm in front, shoulders back and down. Pull the arm in, have his fingers, try to relax the arm. Go with back of the shoulder, turn the palm up to the sky. And that was a short impingement training. I think very much. And until next time.